this is Miss Park, and this video is called Factoring Simple Trinomials. Okay, so first let's talk about what a simple trinomial is. So a trinomial is a polynomial or algebraic expression that has three terms. And we've already seen something like this, ax squared plus bx plus c. This comes from the standard form of a quadratic relation or a parabola, y equals ax squared plus bx plus c. That is called a trinomial. This is called actually a complex trinomial. And I'm going to show you what a simple trinomial is, and you'll see the difference. A simple trinomial doesn't have an a. It just has this, x squared plus bx plus c. So this is the simple trinomial. So this lesson is going to be on factoring a simple trinomial, and another lesson will be on factoring a complex trinomial. Okay, so let's get started. The first thing is to remember that what factoring is. So factoring means writing something as, writing an expression as something times something. Okay, so it is the opposite of expanding, which expanding is really multiplication. So this is, for expanding, you're taking something that looks like a product and doing the multiplication, getting an answer. Here you're going to start with the answer and then write it as a product, something times something. So let's do an example. Okay, suppose I asked you to expand and simplify. So this is the not factoring. This is expand and simplify, something that looks like this. Okay, x plus 3 times x plus 4. We could do this two ways. We could do it with distribution, or we could do it with an area model. Just for fun, let me start this with an area model. Okay, so I'm going to make my little rectangle, and up here I'm going to have an x plus 3 and an x plus 4, and I fill in the little rectangles. So the first one is an x by x, which is x squared. Second one is 4 by x, which is 4x, 3x, and then 3 by 4 is 12. Add them all up, x squared plus 4x plus 3x plus 12. Collect the like terms, x squared plus 7x plus 12. Okay, so that would be a expand and simplify question. But suppose I had a factor question, and the factor question would look like this. Factor x squared plus 7x plus 12. So starting with the answer, right? Starting with the product. We're going to write it as something times something. So here's what we're going to do. We're going to first notice from the expand and simplify that, I'm just going to change color for a second, that this box over here with the x squared has to be there because each of the binomials that we're multiplying begins with an x. So for sure we're going to have an x times an x. So if I'm going to make my area model for the factoring question, the first term I have is an x squared. So I know that one of the boxes is going to have the x squared. Now, the other thing to notice in the expand and simplify is this last box here, the 12. And we get the 12 by multiplying two numbers that don't have x. So 3 and 4 multiply to give 12. So there's my 12 in the factor question. Two numbers are going to have to multiply to 12. All right, so let me start this. Let me start this rectangle. Okay, so remember when we factoring, we're given the area on the inside, but we don't know what goes on the outside. We don't know the dimensions. But here's one thing I know. There has to be an x squared, right? There's an x squared in the question. And the only way to get x squared is for this box, for this side length and this side length to each be x. So now I am working backwards to figure out what those dimensions are. Right? The other thing I know is that in my answer, I have a 12. And so this, the two missing side lengths have to multiply to give 12. Suppose I didn't think of 3 and 4. Suppose I thought of 2 and 6. Okay, this will work because 2 times 6 gives me 12. But what happens is when I go to fill in the other boxes, I'm going to go, this box here has 2 times x, so that's 2x. And this box here is 6 times x, which is 6x. Now when I add them all up, this middle part is going to add up to 8x. And that doesn't match my question. My question has a 7x in the middle. Okay, so we know from doing this that the values that I chose, 2 and 6, are not going to give me 7x in the middle. So let's take them out. Okay, I'm just going to erase this, take them out. I'm going to take out the 2 and 6. I'm going to try some other combination that multiplies to 12. Let's see what else multiplies to 12. Oh, I know, 1 times 12. Okay, 1 and 12. Multiply them out, I'm going to get an x in one of the boxes and 12x in the other box, and those two will not add up to 7x. So I know that that's not right either. So when we factor, sometimes it takes a little bit of trial and error. We're going to try some numbers and see if they give me the question that I'm trying to factor. Okay, and so after trying a few combinations, I can see that if I put a 3 and a 4, or a 4 and a 3, doesn't matter the order, then I'm going to get a 3x here and a 4x here, and that will get, and a 4x here, and that will add up to the 7x. And so I know that I factored it correctly. And so what I will say now is that the original expression is equal to x plus 4 times x plus 3. All right, so look what I did. In the expand and simplify, I started with the two binomials multiplied together, and I got an expression that has no brackets. With factor, I start with an expression that has no brackets, and I end with the two binomials multiplied together. All right, so it's backwards, it's opposite. So let's do another example. Okay, so let me do, let's do it again with expand and simplify, and then we'll do it again with factoring. So let's say expand and simplify, and I'll give you a plus 5 times a minus 1. All right, so I can do this without an area model. So let's try distribution this time. A times a is a squared. A times negative 1 is negative a. 5 times a is plus 5a, and then 5 times negative 1 is minus 5. Add them all up together, a squared plus 4a minus 5. All right, so I'm done. Now, a factor in question would look like this. Factor a squared plus 4a minus 5. All right, let's do the area model here. I know that I must start with an a squared. I know that I must end with a negative 5. I don't know what goes in between. That's going to be my trial and error. So to get an a squared, I must have an a here and an a here. That one I know. Now to get a negative 5, well, what divides into 5? Like what multiplies together to give 5? There's not many options. There's really just 5 and 1. And now it's a matter of, because I want negative 5, should the negative go with the 5 or should the negative go with the 1? So let's try putting the negative up here, and this is a positive, so they multiply to negative 5. Well, now if I fill in the windows, or fill in the little rectangles, this one is going to be negative 5 times a, so that's negative 5a, and this one is going to be plus 1a. And now when I add these all up, I get a squared minus 4a minus 5. And that's actually not the same as my question, because my question said plus 4a. So I know that this combination is not right. So I'm going to change the combination. I'm going to take the negative out of here and put it over here with the negative 1 and make this one a plus 5. So now what I'm left with is this top box is going to be plus 5a, and the bottom one is minus a. And that does give me a squared plus 4a minus 5. So now I know that that's going to equal to a minus 1 times a plus 5. So do you notice what has happened here? When we're choosing the numbers, we need two things are happening, okay? We need to find the two numbers that are here and here. They multiply to c. So when I say c, I mean because it's x squared plus bx plus c, simple trinomial. They multiply to c, but they must also add to b. It means your two numbers multiply to negative 5, but they have to add up to 4. So what are the numbers? Well, they're negative 1 and positive 5. Okay, and that's how you factor that. So I have a few more examples, and they'll get a little bit more challenging as we go. So let's do the next one. Let's do m squared. So example, m squared minus 6m plus 8. All right. This time I won't even use the area model. remember what we need. We need to find two numbers that multiply to C and add to B. So I'm just going to write it on the side. They have to multiply to 8 and add to -6. What could those numbers be? So let's see, what divides into 8? I'm just going to make a little table. I can go 1 times 8. I can go 2 times 4. Is there anything else? No, nothing else divides into 8 because the next one is 4 times 2, but that's already there. 2 times 4 is the same thing. Now, they have to add up to +8, but they have to multiply to +8, but they need to add to -6. So I'm going to have to make a change to these numbers so that they'll add to -6. If they're going to multiply to +8, it means either they're both positive or they're both negative. But if they were both positive, they wouldn't add up to -6. So guess what? I'm going to make them both negative. Now they add up to +8. Sorry, now they multiply to +8 and they add up to -6. And so those will be my two numbers. So I'm going to put m in this bracket and m in this bracket. That's how to get the m squared. And then -2 here and the -4 here. And if you try to expand back to double check, you'll see that this equals the question. Let's do another one. Let's do a few more. Okay, example. So I hope you're writing these down. These are your examples. V squared minus 2v minus 24. All right, so we want two numbers that multiply to -24 and add to -2. So what we have to do here is we have to make a little chart and see, well, what divides into 24? 1 times 24, 2 times 12, okay, go in order. 3 times 8, 4 times 6, 5 doesn't go. Okay, and the next one is 6, but it'll be 6 times 4, which is already here, and then they'll all be repeated again. So I'm gonna need to find some combination that adds up to -2. Now, remember, we have to multiply to -24, which means one of the numbers in the pair will have to be negative. Okay, but I want them to add up to -2. So it turns out that it's the 4 and the 6, but I must make the 6 negative. Now these two numbers multiply to -24 and add to -2. So now I open my two brackets, I put a v in each bracket, and I go +4 here and -6 here. And now it's factored. So just want to show you that this is really just comes from the area model, right? The numbers that we're choosing to go on the outside, they add to the middle term and they multiply to the third term, the last term. Okay, do one more. So let's say I go 10v squared minus 20v minus 240. Okay, so this looks like a complex trinomial. It is a complex trinomial, but I told you this lesson was not about complex trinomial, it's about simple trinomials. So how come I'm including this example, right? The reason I'm including this example is because before you do any kind of factoring, you should always do common factoring first. Remember common factoring, we have to find the greatest common factor. If we can do that, we can make our numbers smaller and easier to work with. Looking at these three terms, the greatest common factor is 10. So I'm going to take a 10 and I'm going to factor it out. And I'm going to get v squared minus 2v minus 24. And now the inside is a simple trinomial. So I'm going to leave the 10 on the outside and factor the inside. I'll just use my answer from above, like this. And what you end up having is 3 factors, right? 3 factors. Usually we have 2. But this is 3 factors because there was a common factor, and then there was the simple trinomial which had 2 factors. So always look for a common factor first. You know what? Let me write that. Always look. So if you're making notes, please write this down, for a common factor first. All right, and let's do one last example. Now this is kind of a super challenge here. So let's see if we can handle it. Let's go. Okay, so for example, again, the instruction is to factor. Okay, so I'm going to give you this. I'm going to call it factor fully. Okay, goes like this, a plus 1 squared plus 3 times a plus 1 plus 2. We want to factor this, which means write it as something times something. Resist the urge to expand, right? The question is not expand, it's factor, which is the opposite. So do not expand. If the question is a factoring question, never expand. That's not what it wants. Okay, so how do we factor this? The thing to do is to notice that it looks like x squared plus bx plus c. Take a look. There's something that's squared, then there's 3 times the same something, and then there's a number on the end. So what we can do is we can do something called, in math, it's called a change of variable. Okay, this is a technique that you'll use in math forever and ever. And it goes like this. Instead of writing a plus 1, which looks a little bit not friendly, I'm going to change the variable to, I don't know, let's call it y. Doesn't matter. And y is going to be this bracket a plus 1. So now what I have is y squared plus 3y plus 2. And I know how to factor this. This is a simple trinomial. And so simple trinomial, you open the two brackets and I put a y here and a y here. And now I need two numbers that multiply to 2 and add to 3. There's not a whole lot that multiplies to 2. It's just 1 and 2. And they add to 3. So it's like this. 1 and 2. And now it's factored. Except the problem is it's factored with y's, and the original question was with a's, not with y's. So now, once we've got it factored, we can put our a's back in. So this equals a plus 1 times a plus 1 plus 2. Because remember, y was equal to a plus 1. And now I just simplify inside here. That's a plus 2 times a plus 3. All right, and this last line here, that is factored. All right, this was a challenge question. So please practice and good luck.